Hello, everyone, and welcome back. This is day 2 of the Wonky Walk Lab. We are going to finish up our lab and make this look really nice. So, yesterday we gathered all of our data. We set up this experiment. So, where we are at today is, now the information that's on mine, don't copy it because this is not good information. In fact, this is probably not speeds that you're going to be getting. Hint, clue, hint. Okay. What we started with yesterday, so we made sure all of our trials were the same. We made sure everything was the same except for the actual walking. Like if we were always having to go up and down or surf, like always go uphill, we made sure to do all of our walks uphill. If we had perfectly flat ground, well then we could go back and forth and get more trials in, right? Today we are looking at our data from our really good test and seeing how good was our test. So first thing we need to do is get all of our averages. Now, yesterday we ended with me showing you how to do one and how to get the speed. If you finish that, wonderful. You can just listen to me and go ahead, start with the graphing. As far as if you need a little helper, we're going to do a few more here now. So to get your averages, remember, we wrote down, you need to add up all the trials and then divide by how many trials you have. So we're going to do that first. We've got, for this first one, and if you want to pause the video and get this yourself for your own, this would be a good time. But if you want to look at this first example, so when I added up all of my hopping numbers, I get 64.3. 64.3 divided by, I have 4 trials, gives me 16 point, and says 075, so I'm going to go 16.1. And then I'm going to do this for all of them. So if you want to do this for yourself, get your own information, go ahead and do that. I'm going to get it for the rest of mine. Okay, if you're hearing my voice right now and you're like, oh, I'm not done, pause the video. Okay, if you're ready, let's go. This is the average speed. So at this point, I'm assuming you have all of your average time. So now we're going to get our speed. Our speed is equal to, we wrote it up here, speed is equal to distance divided by time. And we learned that in our speed and velocity reading. Make sure you read that because it tells us more than just this formula. It tells us what's actually going on behind that, which is going to help us in our next few pages, or on our next page there. So speed is equal to distance divided by time. Our distance was 12 meters, and we're dividing it by our time. So we have 12 divided by 16.1 here. So that gives me 0.74 meters per second. For our next one, I've got 12 divided by 11.1. So I've got 1 point, and if you want to go out to the second, 08. Oh boy, guys, did you catch what I'm already doing wrong? What do we not put in our data table? Labels. You can erase this, make it look much nicer. It wouldn't be a video with Miss Morodic if there wasn't some white out. We don't need our labels, though, because the label is already up here. So 1.08, and then we've got 18, 12. So we've got 0.66. So that's what yours should look like, okay? Now, if you're like, Ms. Morodic, I'm not done, you have the convenience of pausing this video right now. So pause the video if you're not ready to move on and turn me back on when you're ready to. At this point, though, I'm going to assume that you've paused this video if you need to, or you are ready to move on. So our first thing is we need to add a title. Now, if you can come up with an adorable title, that is fantastic. For the Penny Lab, I was talking with Mrs. Carpolinia, and she had some students put, like, raining on Abe because, like, the water was falling on the penny. Adorable. Or Lincoln takes a swim. Adorable. If you can think of something that's clever and cute, oh my goodness, it'll make my day. It'll make your day. Do it. For mine, I'm trying to think of what would be a good, like, wonky walk speeds. Speeds versus different. Mine are usually more scientific. I'm not as creative as Mrs. Carpolini and her students. You guys got to show me up. Until then, I'm going to do different walks, speeds of different walks. Usually if I need to come up with one, I research it, go to thesaurus.com. This will work still. Oh wait, so our first thing is we need to give it a title. Done. On the side here, done. Label our independent and dependent variable. Now I had some people, they like put head and tail here. They put like what we're going to be putting regular walking, speed walking, hopping, but they forgot to put the independent variable. The independent variable is our types of walks. We need to know what these are, like head and tail of what? Regular walk, hop, speed walk, funny walk. What does that even mean? So we've got types of walk. Please write these. So regular walk. Please don't just go RW. Regular walk, hop, speed walk, funny walk. So I've got all those. Up the side, that's where our dependent variable goes. So this is average speed. Make sure you have the unit. It's in meters per second. You need to have all of these parts to get all of the credit. So if you're like, she said it looked really nice, but I lost some credit, it's because I put in the comment, hey, you're missing these things. Please add them. Make sure you've got all the bits and pieces. Now on here, look at our data. What does our data go? We've got 0.6 to 1.08. So maybe we might want to go like by 0.25. Wouldn't be too bad. Because we want to stretch this out pretty well. So if we go 0.25, I think we can even do less than that. We might be able to do like 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I think we can go by 0.1. So let's go 0. And let's not put every single number. We'll just count off a few of them just so it doesn't get as cluttered looking. So we've got 0, 0.1, 2, 3, 4, 0.5, 6, 7, 8, 9. This is 1.0. So we'll do something like that. So then we need to graph these. So my first one, my regular walk, was 0.92, so it won't quite be at the 1. And then the next one was hopping, so 0.74, 5, 6, 6, 7. It's about halfway here. Now, do you notice I am purposely using a folder? I'm using a folder because if you are at home and you're like, I don't have a ruler, well, guess what? I'm not using a ruler either. I don't even know where I got this folder. I don't know why it has, I don't know, but I can use a folder, I can use a notebook, I can use another piece of paper, but I do expect that there are straight lines here. Next one is 1.08, so it's going to be just a tiny bit above. And I like to add all of my lines and then go back and get the other lines. 0.66. Get out here. So now go through and get all the sides of the bars. And if I wrote on yours, like, please use a straight edge. This is what I mean, is please use a ruler. Please use a folder, use a notebook, use a something. Please don't do like, ooh, I'll make it look like they're straight lines because I'll just go back and forth with my pencil. No, make it look nice. See how flat those all are? So I have a good range of numbers. I'm going to use colors and prints. Let's get these averages on the top. So we've got 0.92, we've got 0.74, 1.08, and 0.66. So the only thing I need to add yet here is my colors or patterns. So if you wanted to do colors or patterns, go for it. If you wanted to, your patterns can be freestyle. You can freestyle these if you would like, if it brings you happiness. Like, see my straight lines? They're pretty straight, but you can tell they're not perfectly straight. I can tell when people's straight lines have been just hand-drawn. It's a special skill. So can Mrs. Carpolinia. We took a class on it. I'm kidding, but kind of. So your data table and graph should not look like mine as far as data, but for how neat this looks, that I used a ruler, that I have my variables where they belong, I've got a good range of numbers, I've used most of the space, I've got a title, averages on the tops, that is what I am all expecting. This, if you don't have colors, this is what I'm expecting at the least, is it looks something like this. Now, if me or Mrs. Carpolinia grade and we see that you have these exact same numbers, or don't loophole us and be like, I'll make them just a tiny bit off. No, because we'll see the rest of the stuff doesn't make sense and it doesn't average out. Do the lab. Have some fun. I know, I used the F word and said have some fun, but seriously. So now we need to do which task resulted in the fastest speed. Which one is the biggest average? So you've got to think about this in terms of this one was going 0.92 meters per second versus this one 1.808 meters per second. You're going faster here than you are here. You're going like half a meter per second here versus almost double that here. So which one was the fastest? It's going to have your biggest number. That is, for me, speed walking. Please put your actual. And then what was the speed for mine? Which one was the slowest? For mine, it's going to be the smallest. So it was my funny walk. And remember, it says use your units. I've got my units here. So now we're using a little bit of, like, if you've ever heard of plug and chug, or we're going a little bit into math class. You know how we can rearrange a formula and still get the same answer. It's kind of like if we've got 2x equals 4. I can divide both sides by 2 to get x by itself. That's exactly what the speed formula is here. So speed is equal to distance divided by time, but it's also the same as saying distance is equal to speed times time, which is also the same as saying time is equal to distance divided by speed. They're all saying the same thing, it's just which one is giving us the answer we want here. So, how far in distance could you speed walk in 10 minutes? Remember units, first we need to change our minutes into seconds. So, how many seconds are in a 10 minutes? 10 times 60 seconds gives us 600 seconds. So, we're going to go 600 seconds. So, how far could you speed walk in 600 seconds? I want to know my distance. So because I don't know distance, I'm going to use the formula that's d is equal to speed times time. What this then looks like is d is equal to, we're going to need to put our information times 600 seconds. And then we're going to get our distance is equal to, what do we measure distance in? Meters. What am I going to put in here? I'm looking for my speed walk. So for mine, I'm going to be using 1.08. So for me, I would write in 1.08, and I would write 648 meters, and then square this in or box it in so I know that's your final answer. Okay, now I'm going to get rid of that because that's not going to be true for you all. The next one, how far distance could you funny walk in 15 minutes based on the results for the funny walk trials? So now we've got 15 minutes that we want to change into seconds. So we've got 15 times our 60 seconds. So we get 900 seconds. Which formula are we going to use? Well, we used the distance to find distance before. We're going to use the same one again. Distance is equal to speed times time. So distance is equal to times our 900 seconds this time. So distance is going to be equal to blank meters. What am I putting in this blank here? I'm using my funny walk speed. So for Miss Morodic, mine would look like I'm putting in this 0.66. And when I do 0.66 times 900, I could make it 594 meters. And then I'm going to box it in because that's my final answer. Now, that's not what you guys are going to do, so I'll erase that out so it's not confusing. Because you're going to put your own data in there. And then we're going to see how much time it would take to hop 30 meters. Because, oh my goodness, for both of these, would I want to speed walk for 10 minutes straight? Probably not. Have I? Yes. Multiple times? Yes. For the same reason? Yes. You're wondering what it is? Miss Zane and I trying to get to our car on any of our vacations and trying to avoid a parking ticket. It's a thing. If you want to know more, let me know, but I'll leave it there. But you probably don't want to have to do that for 10 minutes if you can avoid it. Same thing, you probably don't want to funny walk for 15 minutes if you can avoid it. But we can still figure it out just for funsies. So how much time would it take us to hop 30 meters? Because holy buckets, that'd be a very long ways to hop. We want time is equals to distance divided by speed. So we're going to use the time is equal to distance divided by speed here. We're going to substitute this in, and all of these, I'm writing them out, so I'm expecting to see that. So time is equal to 30 meters divided by our speed. Put a box there to kind of leave it there. So then we get our answer is time is equal to blank, and we're going to be putting time is in seconds. So for this one, we're putting our hopping. For Miss Morodic's, mine's 0.74 for hopping. Meters per second. So 30 divided by gives me, it would take me 40.5 seconds. And I'm going to box it in because that's my final answer. Now I'll get rid of it because if you're looking at this, I don't want you to think, oh, that's the same information you use. You're going to use your own data, okay? So that is that page. Now on the back, time to wrap it up. So our conclusion. What was the order from fastest to slowest? What does your graph show you? So if I look at mine, my fastest is going to be speed walk, followed by regular walking, hopping, and funny walking. So yes, I'm going to write the whole thing out. Speed walk. Shoot. Miss Moronic can't remember the whole thing. Regular walk, speed walk, regular walk, hop, and funny walk. Speed walk, regular walk, hop, funny walk. What were our actual results after collecting our data? Ladies and gentlemen, I got real excited there. You see what my problem is? Go ahead, make fun of me, go for it. Actual results, speed walk, regular walk, hop, and funny walk. Okay, yes, I had to use whiteout twice now. Just we all can't be perfect. Wait, so our hypothesis, this is what we predicted at the start of the lab. So I said speed walk, hop, normal walk, funny walk. Speed walk, hop, funny walk. Wait, regular walk, I think it was. Normal walk, funny walk. Okay, Now I've actually got my hypothesis versus my actual. So, do your results match your hypothesis? Yes, no, somewhat, explain. For mine, I did pretty good with speed walking and funny walking, but I didn't have hopping and regular walking, so I'd say somewhat. And now I will explain with complete sentences. There's 3 lines there. Excuse me. I'm expecting to see at least a full sentence, maybe even 2. What are 3 possible errors? Explain using complete sentences. Again, there's multiple lines there. Please do not put everything was good. Do not put none. Do not put IDK or any version of IDK or I didn't do this at school, I'm not sure. None of these or any variation of these are acceptable. What are things that you did that we tried to make a fair test, but they maybe weren't perfect? Now, when I was talking about our controls, remember I said we want to use the same type or pace of our walk. We want to use the same racetrack, and we want to time all of our walks the same way. Did you do something that made it so you didn't time all your walks the same way? Did you do something that your racetrack wasn't the same? Like, were you always going up a hill or down a hill, or were there different trials that you were sometimes going uphill, sometimes going downhill? Was there times where you couldn't do the same walk because you were super tired? Did you wear your different shoes? Did you do this at different times of the day? Was it windier out? Was there anything that might have changed this? Like, were you needing to go somewhere and you're like, oh, I just got to finish this up, so you didn't do a completely great job? None of those fall under everything was good, there was nothing, you don't know, or I didn't do this at school. We get it. We're not at school, but we're still going to do the best we can. So what did make this imperfect? Put what those things would be. And this isn't like you're going to lose credits like, oh, I didn't do this well, so give me an F, Miss Moradic. No, it's like, hey, the next time I do this, or the next time I do a test, as in like an experiment, I can remember to do these things. We want to learn from what we did. It's kind of like with the Penny Lab. Some people realized that they had a slanted desk. So for a next test, they're not going to use a slanted desk if we would have that. Someone was like, my partner was shaking the table the whole time. They probably would go to a different table, or at least not near that partner that was shaking the table, right? There are things that made it an imperfect test. I'm sure at home you might have had the same thing. Like maybe you had a little sibling running around and like bumping you, so it didn't work out quite well. That did not mean that Miss Moradic had anything to do with it. It just made an imperfect test. It's what would you do better? So then our last one is what would you do to make this lab better or more accurate? So I kind of just said some like from the Penny Lab. They wouldn't use a slanted desk because they'd use a flat desk. They wouldn't use the shaking table because they'd use a flat table. Now, again here, do not put any of these down here. Okay, if you were going to do this test again, what would you want to do? Do you want a different area? Do you want to do different trials? Do you want to do a different type of walk? Do you want to do, maybe when we did the Penny Lab, I had someone tell me that they tested different years of pennies. So they just went ahead and did an extra experiment on their own on the side. That was wonderful. Maybe you're going to do this lab and you're like, you know what, I'm having kind of some fun. I wonder what happens if I run. Or I wonder what happens if I roll, or somersault, or cartwheel. Please, if you're into somersaults or cartwheels, please be careful. If you're like in gymnastics and you're confident with that, go for it. I've had some people that are like, I can do one, and then they just kind of fall on their face. Please don't. But other things, what would you do if you could do this lab again? Okay? Do that, write this, submit it in. You, I'm sure, can have an awesome lab because the first batch of them looked real nice. I'm expecting the second batch to look just as awesome. As always, let your teacher know if you have any questions. We are here to help. Otherwise, have a good day, everyone. Goodbye.